Rolling.
Welcome to Good Morning Long Island.
Thanks, it's nice to be here.
So you're looking at cancer, one of the diseases or set of diseases, I guess is a better way to put it,
Sure.
that affects the most people, I guess.
It does.
Close.
I think it either affects you or you know someone who it's affected.
Absolutely. So what are you doing, and why should our audience be aware of it?
So as a cancer community, we're facing, I would say, two big issues. The first is we don't understand how cancer starts in the first place. And the second is we don't understand how cancer is able to become resistant to the treatments that we spend all this time and money working on. So these are two big mysteries that we're still not totally sure how to address right now.
All right. So what are you doing to help us address that?
So I'm not the first person to bring up both of these issues. These are something people have been thinking out for a long time. The reason we haven't made as much progress as we want is because we don't have the technology available to give us the answers to these questions. So rather than struggling with this old technology, what we're doing is trying to develop a new system that'll allow us to answer these questions more fully.
All right. So when you say technology, that's a big field. What are you really talking about?
So we have a new system to study cancer. So if you were to look at a tumor, you'll just see a bunch of cells. So some of these cells are not doing much of anything. They're just existing. A lot of them are just dying. So there's a small group of cells that's dividing very rapidly and giving rise to the tumor. There's a small group of cells that's going to metastasize and help the tumor spread throughout the body. There's another small group of cells that's going to allow the tumor to resist treatment. So just by looking at a tumor, we don't know which cells are which.
Oh,
so we have a technology that we're calling genetic barcoding. So you can think of it like barcodes in a store where if you scan a barcode, you know what the product is and you're able to track that product. So what we're doing, we obviously can't put barcodes onto cancer cells. So we're using little pieces of DNA that function similarly to barcodes.
So little pieces of DNA, are you inserting that?
Right. So we're inserting a unique piece of DNA into each cell.
And therefore you can track.
Exactly. So now we're not looking at just this mess of cells. We're looking at a very ordered structure. So if we see a tumor that resists treatment, we can go back and look at these barcodes and say, I know I put these barcodes in these cells. So I know these are the cells that are resisting the treatment. So what is it about these cells? Or we can look at a metastasis and say, look, I'm seeing this barcode over and over again in this metastasis. What is it about this group of cells? So it's no longer just this big blob of cells. We now have an area where we want to focus and find out what is it about these cells that are allowing them to cause the tumor to grow or cause it to.
It sounds like you have already developed the technology, if I hear you correctly.
So we have developed this technology. We actually developed it in yeast. So it's a little complicated to then get it into cancer cells. So that's what we're working on right now. The nice thing about this technology is that once we get it to work, we can study any kind of cancer. It's not something that's limited to lung cancer or brain cancer. It can be
So
any kind.
DNA barcoding.
Barcodes,
I love it.
exactly.
Thank you so much.
Thank you.